The hole is smaller than a pin, and that's exactly why he doesn't notice it straight away. He's still moving, still working, still breathing, when something quietly changes. His next breath feels thinner than the last one. Not painful, just less satisfying. And that's where that tiny hole is doing more than it should. Inside the suit, air is being held under pressure to keep his body working normally. The moment that pin-sized opening forms, air begins slipping out into space, and pressure inside the suit starts falling with it. That pressure is doing more work than most people realise. At sea level on Earth, air presses against the body with immense force. The body pushes back with equal pressure from within. A spacesuit maintains a carefully engineered version of that balance. Even a slight change in internal pressure begins shifting how gases move through the lungs and bloodstream. The system is stable, but only within a narrow range. On Earth, oxygen pumps into the blood every time you breathe. But in space, as the suit loses pressure, oxygen starts behaving differently. It doesn't move into the bloodstream as efficiently, and in some places, it begins to lose oxygen altogether. His body reacts immediately. His heart speeds up, trying to pump more oxygen to the vital organs. His breathing becomes faster, but each breath is doing less than it did before. The oxygen reaching his brain starts to drop. That's when things begin to feel off. His hands don't respond as precisely. Simple movements take more effort. The problem in front of him suddenly feels harder to think through, even though nothing else has changed. As the pressure inside his suit drops, moisture lining his mouth, and airways begins turning into a gas. Not only is oxygen struggling to enter his blood, carbon dioxide is building up, and his blood chemistry drifts out of balance. Breathing, circulation, and brain function are still running, but they're no longer staying in sync. This is where the real danger appears. As oxygen delivery becomes unreliable, his ability to recognise the situation and fix it fades at the same time. The brain systems that would normally solve the problem are the first to be affected by the lack of oxygen. If pressure is restored quickly, those systems can recover. What makes this unsettling is how little it takes. In space, even grains of dust travel fast enough to turn impact into penetration, quietly punching through material designed to keep him alive. And because space is full of moving debris, the threat isn't rare or cinematic. It's constant. At any moment, something as small as a grain of sand can begin the chain reaction that starts shutting a human body down.